All right, we are studying right now chemistry. I might feel cold, so it's pretty much distracting. Let's leave it. So we have reached in chapter 2. What's ahead? The atomic theory of matter. We begin with brief history of the nation of atoms, the smallest pieces of matter. Then the discovery of atom structure. We then look at some key experiments that lead to the discovery of electrons and to the nuclear model of the atom. The modern view of atomic structure, we explored the modern theory of atomic structure, including the ideas of atom numbers, mass numbers, and isotopes. Not need this. Atomic weight, and then periodic table. Atoms, molecules, and ions. Look around at the great variety of colors, textures, and other properties in the material that's around you. The color in a garden, the texture of the fabric in your clothes, the solubility of sugar in a cup of coffee, or the transparency and beauty of a diamond. The materials in uh, our world exhibit and strike and seemingly infinite variety of properties. But how do we understand and explain them? We make we make diamonds transparent and hard, where table salt is brittle and dissolved in water. Why does paper burn and why does water quench fires? The structure and behavior of atoms are key to understand both the physical and chemical properties of matter. Although the material is our world very greatly in their properties, although the material in our world very greatly in their properties, everything is formed from only about 100 elements and therefore from only about 100 chemically different kind of atom. In sense, the atom are likely the 26 letters of English alphabet that join in different combination to form the immense number of words in our language. But what rule govern the ways in which atom combines? How do the properties of substances relate to the kind of atom it contains? Indeed, what it is what is an atom like, and what makes the atom of one element different from those of another? In this chapter, we examine the basic structure of atoms and discuss the formation of molecules and ions, thereby providing a foundation for exploring chemistry more deeply in later chapter. What is wrong with this? How can I fix my under eye bag? How can I do that? called the atomic theory of matter. Philosophers from the earliest time speculate about the nature of the fundamental stuff from which the world is made. Democritus, 460 to 370 BC, 460 to 370 BC, and other early Greek philosophers describe the material world as made up of tiny individual particles they called atoms, indivi- indivisible or uncuttable. Okay, indivisible and cuttable atoms. Later, however, Plato and Aristotle formulated the notion that there can be no ultimately indivisible particles, and the atomic view of matter faded off many centuries during which Aristotle's philosophy dominated Western culture. The notion of atoms emerged in Europe during the 17th century as chemists learned to measure the amount of element that react with one another to form new substances. The ground was laid for an atomic theory that linked the idea of element with the idea of atom. The theory comes from the work of John Reuben during the period of 1803 to 1807. Dalton atomic theory was based on the four postulates. Dalton's theory explains several laws of chemical combination that were known during his time, including the law of constant composition, based on what, what's this fucking time? Okay. In a given composition, the relative number and kind of atoms are constant. It also explains the law of conservation of mass based on postulate. The total in a given compound, the relative number or kind of atom are constant. It also explains the law of conservation of mass based on postulate. The total mass of material present after the chemical reaction is the same as the total mass present before the reaction. Okay. The good theory explains known fact and predict new ones. The good theory explains known fact and predicts new one. Dalton used this theory to deduce the law of multiple proportions. If two elements A and B combine to form more than one compound, the masses of B that can combine with a given mass of A are in the ratio of small whole numbers. Dalton's atomic theory. Each element is composed of extremely small particles called atoms, and atoms of the element oxygen and atom of the element. Each element composed of extremely small particles called atom. Oxygen and nitrogen atom. All atoms of given element are identical, but the atom of one element are different from the atom of all other elements. Atom of one element cannot be changed into an atom of different element by chemical reaction. Atom are neither created nor destroyed in chemical. Atoms are neither created or not destroyed in chemical reaction. Okay. Oxygen cannot be nitrogen during reaction. Oh yeah. Compounds are formed when atoms of more than one element combine. Compounds are formed where atom of more than one element compound. A given compound always has the same relative number and kind of atom. Nitrogen, oxygen, okay. So much in case involved that receive the action reference indicate a link to the ideas presented earlier in the text. We can illustrate this law by considering water and hydrogen peroxide, both of which consist of the element hydrogen and oxygen, forming water. 8 gram of oxygen combined with 1 gram of hydrogen, 8 gram of oxygen combined with 1 gram of hydrogen, forming hydrogen peroxide. 6 gram of oxygen combining 1 gram of hydrogen, thus the ratio of the mass of oxygen Thus, the ratio of mass of oxygen per gram of hydrogen into two compound of 2 is to 1. Using Dalton atomic theory, we concluded the hydrogen peroxide contained twice as many atoms of oxygen per hydrogen atom as does water. Okay. Compound a compound A contained 1.33 gram of oxygen per gram of carbon, whereas compound B containing 2.666 gram of oxygen per gram of carbon. What chemical law do this data illustrate 2 is to 1? Dalton's atomic theory. If compound A has an equal number of oxygen and carbon atoms, what can we conclude about the composition of compound B? Compound A has an equal number of oxygen and carbon atoms. What can we conclude about the composition of compound B? Discovery of atomic structure. The discovery of atomic structure Dalton based his conclusion about atom on chemical observation made in the laboratory. Neither he nor those who followed him during the century after his work was published had any direct evidence of the existence of atoms. Today, however, we can measure the properties of individual atoms and even provide image of them. As scientists develop methods for probing the nature of matter, the supposedly individual atom began to show signs of a more complex structure. Today we know that the atom is composed of subatomic particles. Before we summarize the current model, we briefly consider a few of the landmark discoveries that led to the model. We will see we will see that the atom is composed in part of electrically charged particles, some with a positive charge and some with negative charge. As we discuss the development of our own current model of the atom, keep in mind this fact: for particles with the same charge repel one another, whereas particles with unlike charge attracts one another. Cathode rays and electrons. During the mid-80s, 1800s, scientists began to study electrical discharge through a glass tube pumped almost empty of air. When a high voltage was applied to the electrode in the tube, radiation was produced between the electrode. This radiation, called cathode rays, originated at the negative electrons and traveled to the positive electrode. Although the rays could not be seen, their presence was detected because they cause certain material to fluoresce or to give off light. How do we know that cathode rays travel from cathode to anode? So cathode rays originated at the negative electrode and traveled to the positive electrode. नेगेटिव से पॉजिटिव की तरफ ट्रैवल कराना है. Cathode negative electrode to the anode positive electrode. The tube contains a glass green set diagonally to the electron beam that fluorescence, showing the path of cathode rays. The rays are deflected by a magnet. If no magnetic field were applied, would you expect the electron beam to be deflected upward or downward by the electric field? Excuse me. Experiments show that cathode rays are deflected by electric or magnetic field in a way consistent with there being a stream of negative electrical charge. The British scientist J. J. Thomson, 1860, 1856 to 1956 to 1940, observed that cathode rays are the same regardless of the identity of cathode material. In a paper published in 1897, Thomson described cathode rays as Thomson described cathode rays as a stream of negatively charged particles. His paper is generally accepted as a discovery of what became known as the electron. Thomson constructed a cathode ray tube having a hole in the anode through which the beam of electron passes. Electrically charged plate and the magnet were electrically charged plate and magnet were positioned 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 perpendicular to the electron beam, and screen was located at one end. The electric field deflected the ray in one direction, the electric field deflected the rays in one direction, and the magnetic field deflected them in the opposite direction. Thomson adjusts the strength of the field so that the effect balance each other, allowing the electrons to travel in a straight path to the screen. Knowing the strength that result in a straight path made it possible to calculate a value of 1.76 to the into 10 to the power 8 coulombs per gram. So the ratio of the electron's electrical charge to its mass. Once the charge to mass ratio of the electron was known, measuring either quantity allowed scientists to calculate the others. In 1909, Robert Millikan (1868–1953) of the University of Chicago succeeded in measuring the charge of an electron by performing the experiment described. Why not to have something because I'm hungry? It's 5 o'clock in the morning, but I think I should drink something. Actually, also I'm getting a bit distracted. So